Flex USA's webinar on elastomeric insulation's use on mechanical systems. Today we'll discuss the benefits and applications of elastomeric insulation on things such as piping, ductwork, and vessels. With a history of K-Flex USA. K-Flex is part of the Isolante K-Flex Insulation Group, which is truly a worldwide organization. We have production facilities in 8 different countries. K-Flex is headquartered in Milan, Italy. The North American product is made production facility outside of Raleigh, North Carolina in Youngsville, which is also the headquarters of K-Flex USA. Some history about the company. You'll see on this slide some names such as Rubitex and Halstead, with a lot of history in the insulation industry. Through a series of mergers and acquisitions, K-Flex USA has acquired both the rights and the products from Rubitex and Halstead, meaning that while we have established approximately 15 years ago, we have a longer history in the insulation market here in North America, back to the mid-60s and 70s when Rubitex and Halstead were formed. Description on the main products that K-Flex manufactures. Products are a closed-cell, flexible elastomeric foam for thermal and acoustic insulation. They're composed of 3 main ingredients. The first is NBR, which is a nitrile butadiene rubber, and P blend. In addition, there are environmentally safe fillers, flame retardants, and additives, all of which are CFC, HCFC, and PBDE free. And finally, there's an EPA-registered antimicrobial agent in the mix to prevent any type of fungal growth on the product. We produce materials in tubes, sheets, and fittings of different diameters and thicknesses up to 2 inches. And applications include piping, ductwork, and vessels with process temperatures from 297 up to Fahrenheit to plus 220 Fahrenheit for our standard product, and up 300 degrees Fahrenheit for our high temperature product. Showing the production process of our materials. On the top left picture, you'll see the fine before extrusion. We call this final batch. They're sheets of very dense rubber with all of the fillers, flame retardants added in there. From there, they're into the extruder, and from the extruder, they might have an extruder head that you can see in the top right-hand picture. This has changed depending on the type of product we're manufacturing that day and the wall thickness and diameter. To a 220-foot long oven that has 7 different stages. That's where insulation is baked and it's expanded into the form that you're familiar with. And from there it goes into our cutting and packaging lines, all of which are automated, and then finally to distribution and out through the field. Our product include the closed cell structure, which we'll talk about in more depth later in this webinar. The closed structure gives us such benefits such as resistance to water vapor transmission, which will also be discussed later in the webinar. Also non-toxic, it's got a UL Green Guard certification. The fluidity, we are ASTM E84 rated 2550 up to 2 inch thickness. We're flexible down to minus 40 degree Fahrenheit ambient temperature. We like to say our product offers a total life cycle cost because we do offer a complete insulation system. Not just insulation itself. We also have accessories, adhesives, pipe supports, and everything you need to complete the full system. We review the benefits of an effective insulation system. With material selection, thickness, installation, and maintenance, the insulation system will provide energy savings, condensation control, moisture intrusion prevention, and protection, which are things that we're all familiar with. Things that we may not think of are improved equipment performance, mold and resistance on the piping and ductwork in the process, reduction, protection from burns on both the hot and cold side, and finally process control, meaning that if we put 40-degree water in one end of the pipe, ideally we want 40-degree water to come out of the other end, and a proper insulation system will help with that. In this webinar, we'll discuss some thermal insulation fundamentals. We will review some material types, the heat flow in insulation materials. We'll take thermal conductivity and the effects of moisture in an insulation system. From there, about the resistance to moisture intrusion and why it's important, and what the closed structure of elastomeric insulations brings to the table. Reviewing the common insulation material types. 3 main types of insulation materials. The first, fibers, that consists of your glass and material and mineral fibers that you may be familiar with. Second, cellular. This includes your cellular glass, elastomeric foams, your phenolic resins, polyethenes, polysos, polystyrenes, and your polyurethanes. The last being your granular, which includes your calcium silicates and your perlites. The main way from here is that these are all very, very good insulation materials, but to be properly applied. Not all insulation materials are created equal, and some are better in certain situations than others, and we'll discuss that as we go forward. Heat from insulation materials. So thermal energy, also known as heat, always flows from the warmer body to the colder body. You see in the picture in the bottom left, we've got a hot box on the left and a cold box on the right. With the insulation system, those temperatures will equalize, giving us the pink box on the right-hand side. And an insulation system is trying to avoid. We want to try to keep the hot side hot and the cold side cold. And with the proper material and insulation, we can accomplish that. So just a quick review on heat flows through materials. The transmission of heat in an insulation material simultaneously involves more than one mechanism of heat exchange. Those three mechanisms, which may be reviewed for most of us, are conduction, convection, and radiation. Energy transmitted by direct contact, convective energy exchange in fluids, and energy transmitted through electromagnetic waves. Again, a proper insulation system will flow the heat flow by all three methods. So let's thermal conductivity. This is one of the most important aspects of the insulation system. It's the property that measures the material's ability to conduct heat. The units measure in our system is BTU, inches per hour, foot square, degree Fahrenheit, or in the metric system, watts per meter K. The takeaway here is the lower the K value, the higher the insulating value. So the inverse of the R value. With these, you want a higher number to get a better insulating value. The K, the lower, the better here. It's also important to remember that it's not a constant. It's with temperature. Insulation materials are the standard are generally measured at 75 degrees Fahrenheit. Can be measured at different temperatures, including 32 Fahrenheit, 100 Fahrenheit, 200 Fahrenheit. So when comparing insulation materials, it's important to compare the K value, measure the same temperature. Insulation materials have a thermal K between 0.23 and 0.31, which is a fairly tight range when you consider thermal K of other materials such as water, which is 4, and we'll get more into that here in a little bit. Thermal K of steel is 360. K of copper is 225. Above its point, materials stop becoming insulators and they become conductors, such as copper and steel. I pointed out the K of water in the previous slide because it has a pretty profound effect on insulation. The value of 4 for water is about 16 times greater than your typical insulation K value, which water is more of a conductor than an insulator. The thermal conductivity will increase as the moisture content of the insulation material increases. So far you can see it shows the moisture content of a fibrous insulation and the resulting thermal conductivity as that moisture content increases. The chart that as your content increases, the K value increases fairly quickly. It's almost exponential, so you don't need a lot of moisture to degrade the performance of an insulating material. A quick analogy for this is I'm sure we've all picked up a hot pan out of the oven with a wet dish rag. If we pick it up with a dry dish towel, we burn our hands, but if the dish towel is wet and we pick up that pan, we are going to get a burn there. That's because moisture does conduct heat much, much better than a typical insulating material. The main takeaway here being keep our insulation system dry so the performance maintains through the life of that system. Resistance to moisture intrusion is so important in your insulation system. Water permeability measures a material's ability to resist penetration of moisture from the air. These are perms inch, or very, very thin materials. It's generally just referred to as perms. Higher resistance to moisture intrusion, the greater the consistency of performance over time. As we just saw in the previous slide, over time moisture does introduce itself to an insulation system, the performance will go down. We want to try to keep it dry to keep that performance stable. Condensation formation on pipe or duct surfaces is also the main cause of corrosion, another thing that we're trying to avoid with a proper insulation system. Important to know that an ASHRAE Class 1 vapor retarder is defined as materials having a water vapor permeability less than or equal to 0.1 perm. Vapor permeability insulation varies greatly depending on material, gem, etc. So it gives us a water permeability for our products. Well, that's from our closed cell structure of elastomeric insulations. What this means is there are small individual cells with a physical barrier that are separated from one another. What gives us an intrinsic barrier to moisture vapor intrusion, a low and constant thermal K without the need of an additional vapor barrier. Also strong mechanical properties, they're physically bonded to each other, and natural inhibitor of bacterial growth. Bacteria can't spread within a closed cell structure because it's physically trapped within one cell and it can't penetrate through the cell walls. It's also something that we like to call distributed resistance. With a cell type of insulation, if there is a slight tear or rip in the outer jacket or the outer skin, there are millions of closed cell behind that skin providing protection from water vapor penetrating through the material. With fibrous or open cell insulation system, if that jacket is penetrated and there's a point of failure, we can then penetrate through that point of failure and migrate through the entire system without distributed resistance behind it. We're going to discuss some thermal insulation applications. We'll start with chilled water applications. Some application considerations for chilled water systems. The big here is the vapor drive. The chilled water pipe has what we call vapor drive. It's a high level of moisture vapor pressure in ambient air trying to move to the low pressure air surrounding the insulated pipe surface. And now an insulation system will prevent the moisture vapor from hitting the surface and condensing. Insulation is essential for adequate system performance. Some ways from here are also to turn on a chilled water system before a building is enclosed. This may create an unconditioned space that the insulation system was not designed for. The system is designed for indoor applications and the building is not fully enclosed. The temperature and humidity values may be at a point where condensation will occur even if the insulation is already installed. If a fibrous or any type of open cell insulation system in this case, you start getting moisture penetrating through into the insulation system from day one, which could cause performance issues later on in life. And just a quick takeaway here as well, to replace a failed system is generally 3 to 5 times the initial cost of installation. Vapor intrusion is the single most destructive factor to insulation. Is for every 1% moisture gain, the insulation efficiency drops by 7.5%. Moisture inevitably accumulate in permeable insulation, even with a concentrated vapor retarder jacket. An improper installation also increases the risk involved with permeable insulation products, ion jacketing as a primary vapor retarder. So down here at the bottom are something that we're probably all very familiar with. You see some of mold growth coming through that white all-surface jacket here on the left. Now you see where insulation was cut away, possibly to repair a fitting or replacing an insulation system, and then the insulation was not repaired or put back, corrosion that you see there on the right. These are things that can potentially be avoided with a closed cell insulation that doesn't allow moisture to penetrate through and into the insulation system. Again, showing the water vapor permeability of several different insulation types. On the left here, you see cellular glass with a permeability well below the ASHRAE Class 1 line. Next to that is an unjacketed fibrous insulation that has a permeability around C5. Further, you have polyiso, which has permeability slightly over 1, which is between ASHRAE Class 2 and 3 vapor retarder. After that, you've got the phenolic, slightly below 1, and then finally K-Flex Elastomeric, which is below 0.1 ASHRAE Class 1 vapor retarder. So important. This shows the effect of thermal K on an insulation system over time. In this scenario, the conditions include an ambient temperature of 90 degrees Fahrenheit, a process temperature of 40 degrees Fahrenheit, and a relative humidity of 85%. So this would be an outdoor application. Pipe size of about 4 inches, and insulation thickness of 2 inches. And what we show here is that over time, the the system with a higher water vapor permeability will eventually get a higher thermal K due to moisture intrusion in that system. The solid black line shows fairly stable thermal K over the 10-year life cycle of this insulation system because the low initial water vapor permeability prevents moisture from penetrating into that system. Where on the opposite end of the spectrum, the dashed line shows a insulation system with a permeability of 1 on day 1. Over time, moisture will accumulate in that system, which will drive up the thermal K, which will cause you to lose the efficiency of the insulation system. It may cause you to lose the efficiency of your piping system and the water temperature there. It may lead to mold growth and corrosion under that insulation. So keeping the insulation system dry, keep performance stable over the life of that system. It shows that compares some standard water insulation types through various performance metrics that we generally look at. The water vapor permeability, surface temperatures, densities, so on and so forth here are compared for elastomeric, glass, fibrous insulations, polyols, and phenolic. Is a reference chart should you ever have any questions. There's some advantages for using elastomeric insulation on chilled water systems. Those are that it's flexible, it's non-breakable, and easily conforms to uneven surfaces. It's light and easy to handle. It's prone to damage from installation errors and job site abuse. It's sandal with no protective clothing or respirators required. It's zip and fiber free. Installed on-site faster with 6 foot lengths and fewer joints. Available with PSA, which is a pressure-sensitive adhesive, which is the use of contact adhesive on-site. Bands or on-site application of complex retarders are required. We've got factory fabricated solutions and offset fabrication opportunities, and it's also non-dusting, which reduces time spent vacuuming and screening work and cleanup after the insulation is installed. Study that we've put together here is for a project called the California Street Thermal Plant. This is a district chilled water facility located in Omaha, Nebraska. They had about 2,500 chilled water in this plant. The application was 38-degree chilled water, and domestic water, with piping ranging from 6 inches up to 42 inch. The owner is Omaha Energy Systems Company. It was installed in 2003 with K-Flex LS tube and sheet. Elastomeric was specified because of its reliability against condensation and its secure fitted seams. We went out in 2012 and performed an inspection. We found no evidence of condensation or insulation failure. We've got pictures showing complex geometries and the large and small pipe that were insulated. You can see that there were some pumps, piping, liners, and other fittings that were insulated here. The flexible feature of the product made insulating those fittings and complex geometries relatively easy, and time has shown that it's held up very, very well over those 10 or 12 years that it's been installed with failures of condensation forming. Chilled water, we're going to look at the next application, which is duct lining. This is a little different because duct liner is typically more of a acoustic material as opposed to a thermal material. I'll get into that here in a second. As mentioned, duct lining is primarily specified to reduce noise and not to be a thermal material. The good thing about a close elastomeric duct liner, it does perform acoustically very well at the lower to mid-range frequencies, which is where a lot of the equipment noise and rumble is located. Your higher pitch frequencies above 1,000, 2,000 hertz are generally from an airflow issue, which means that the system needs to be rebalanced. Here show that reduction really centers around those lower to mid-range frequencies, which can reduce your compressor and fan rumble noises, which are very distracting to occupants in the space. Below show sound absorption and decibel reduction, various thicknesses for K-Flex duct liner, both and attached to ducting, and compared to fiberglass liners and other semi-closed cell foam duct liners. So to note, the closed cell ductwork also gives us the energy conservation that I discussed earlier in this presentation. So more than half of the energy use in commercial buildings is attributed to creating a conditioned environment. With proper insulation, heat loss through duct walls can be considerable and lead to excessive energy use. SMACNA also has a 5% moisture intrusion for fiberglass liner, and as discussed earlier, that moisture intrusion will reduce the performance of the insulation material over time. So again, as with insulation, we want to keep duct liner clean and dry to keep both the performance stable over time and to reduce any instances of mold or fungal growth inside the ductwork. Discussed is the IAQ, or indoor air quality control, that can be attributed to a closed cell duct liner. Then we'll keep the interior of the duct dry with no moisture accumulating inside the clerk space, which will resist mold growth. It can also prevent condensation from forming on the outside of the duct, which will prevent any condensation forming, dripping down to the space below, resulting in callbacks and other maintenance issues. Comparing some duct lining insulation types with flex duct liner gray, fibrous duct liner, and semi-closed foam cell foams compared here with the standard metrics. Again, it discusses things such as your thermal K, your water vapor permeability, your flammability ratings, your density, and so forth. Just they're good charts here. Project references. There's many, many more projects than this across the country, but here's just a quick list of a few. So a lot of these are located in Pennsylvania. I think this is due to litigation in decades past about asbestos and fibrous insulation materials being used in public buildings. As a state quickly went to fiber-free insulation materials in all public buildings, and they're a little bit ahead of the curve there. So we do have hundreds of and project references across the country for our duct lining product. Duct lining is duct cover, where this is installed on the exterior of the ductwork and into the insulation. Generally, for outdoor applications, you do need a type of jacketing, and we offer several jacketing products that I'll discuss here a little bit later. I'll show you some pictures of them first, though. The first top two pictures on the left showing our WT-clad product. This is an indoor application in a manufacturing facility in Tennessee. You get the jacketing. It gives a nice, very clean aesthetic look, and it also allows the insulation to be wiped down. The WT-clad is also NSF approved, that's National Sanitation Foundation, for prep and deli areas, so it can be used in manufacturing areas such as this. The pictures below it are the A-clad product used at the Dallas-Fort Worth International Airport. Again, it protects the insulation from UV and weather degradation, and gives it a nice, clean, aesthetic look. And finally, the two pictures on the right show your ductwork a hospital out in Colorado. The clad is a very similar appearance to sheet metal, so architects tend to like the aesthetic look of it, and you can see the complete system with the seam tape gives a similar finish. Not only does it look very nice, but it also provides the protection that we need for outdoor applications from UV, weather, and what have you. The product offerings that USA has. All products are third-party tested and certified. We offer the broad size range, up to 2-inch thickness, tubes, sheets, and fittings. We take a systems approach. That it's not just the insulation material, but we have a factory-applied PSAs and claddings, factory-fabricated fittings, and a line of tapes, adhesives, and pre-insulated pipe hangers. A lot of our products are NSF approved. We have UL Green Guard certifications. We're Free Mutual approved. Importantly, we're made right here in the United States. The tubes conform with ASTM standard C534, Type 1, Grade 1, non-slit form for slot applications, or pre-slit, pre-glue for retrofits. The top picture is the non-slit form. The bottom picture is the pre-slit with the overlap tape. So you can see you have the peel and stick adhesive on the longitudinal seam, as well as on the overlap tape, which provides extra seam security security and a layer of protection for water penetration penetrating through that seam. Available in black or white, and thick from 3/8 of an inch up to 2 inch, and it's ASTM E84 2550 all the way up to 2 inches. Range for these are for the process is from -297 Fahrenheit up to 220. This product is 0.245, and the vapor permeability is less than 0.01 per inch, which, as you know, is well below the ASHRAE Class 1 vapor retarder line. Sheets and rolls. These are ASTM standard C534 Type 2 Grade 1. These are used on large pipes, ducts, or vessels, available with or without the factory applied PSA, which is your pressure sensitive adhesive. These available are from 1/8 of an inch up to 2 inches, again 2050 rated all the way up to 2 inches. 3-foot by 4-foot sheets or in 48-inch wide rolls. Same temperature range, thermal decay, and water vapor permeability as the tube product. Next is Flex Ductner Gray. This is with the ASTM C1534 Type 1 standard. Available for rectangular, oval, or round ducts. Available with or without the factory applied pressure sensitive adhesive. The gray and thickness is from 1/2 inch up to 2 inches. All of 2550 rated by E84. Standard width product is 46, 47, 48, 56, 59, or 60-inch rolls on the coil line that it will be run on. The reduction coefficient is 0.55 at 1 inch, which won by ASTM C423. Temperature range for this product is from -40 Fahrenheit to +220. And the RU at 1 inch is 4.2, and at 2 inches is 8, which applies with most local codes. And the vapor permeability of this product is less than 0.06 per inch, which is below that ASHRAE Class 1 vapor retarder line. Our line of clad jacketings, alternative to the traditional PVC or metal jacketing, it's a multi-ply laminate that consists of a base layer of PVC, a little in the middle, and a top exterior layer of a UV-resistant mylar. That's our clad AL or a clad white product. We also have a CE polymeric jacket, which is geared more towards industrial projects, our clad IN product. They're all available in roll form to protect all insulation types, not just elastomeric. Our multi-laminates is 0.012 inches for our clad L and clad WT, or 0.045 inches for the clad IN. The vapor permeance is 0.001 perms. It's got a very high emissivity value of 0.8, and it's available as an option factory adhered to K-Flex tubes and sheets, so your single-step installation process. WT, which is the white color, is ASTM E84 2550 rated and NSF approved, so it's very used indoors in food areas or any type of high traffic areas that may require that type of rating. Fitting covers and tapes available that match the finish of the jacketing to give you a complete system. Chart pairing the K-Flex jacketing types and coatings to other jacketing types in the industry, showing a variety of metrics that we use to measure these types of products, from flexibility to UV resistance to vapor resistance, so on and so forth. I think this is a good to reference if any questions do come up later. A couple of quick pictures showing the clad IN jacketing in an industrial application. You can see that we've installed and provided jacketing for a gasification plant here in North Dakota. That's what these pictures show. The clad IN jacket is geared very well towards these applications due to its thickness and its resistance to penetration, and also a level of corrosivity in these environments. K-Flex Eco product, ASTM C534 Type 2 Grade 3. It's tubes, sheets, and factory-made fittings. It's available in ½ inch up to 1 inch. Temperature from -297 Fahrenheit to +250. This halogen-free insulation material, which is for high stainless steel applications. On the applications, a non-halogen-free material has higher levels of leachable chlorides, which will erode stainless steel. The E product and all halogen-free products have lower levels of leachable chloride, so it will not corrode stainless steel in these applications. The pH of this product is 0.27. Water vapor permeability is less than 1, and it's ATM E4 2550 rated up to 3/4 of an inch. And it also contains an electric boat 4013 and IMO approvals for marine applications. We also have a line of K-Fit fittings. These are made elbows, T's, P-straps, and grooved fittings. ATM C534 Type 1 Grade 1. They're available in black or white with thickness from 3/8 inch up to 2 inches, all of which are 2550 rated by E84. Same range, thermal K, and water vapor permeability as our standard product. The benefits of these fittings is that it reduces installation time and cost by the contractor in the field. It provides compression fit, uniform fittings with water seams that were made in a controlled environment and repeatedly made in that controlled environment. So you've got the same level of quality in the fittings that you do as in the insulation material. Our accessories include contact adhesives. Our quick dry adhesives are 320 and 620. Our tack adhesive is the 373. We also have a low VOC adhesive, our 720, or temperature, which is the 420 adhesive. And we've recently introduced our water-based 1120 adhesive. We do adhesives. We have a full line of elastomeric foam tapes, protective UV, and insulated pipe supports. The benefit that K-Flex offers is our ISOCalc program. This is for engineers or users that need to take a look at what this insulation would properly fit their application. It's a very quick and easy to use program where you just input several parameters such as ambient temperature, temperature medium, the diameter, and this will calculate the thickness of insulation required to prevent a certain level of heat loss, prevent condensation, to give you a specific surface temperature. Easy to use program that's available for free download on our website. This is our webinar. Thanks for listening, and if you have any questions, please feel free to contact your K representative.